because the information in this message would be based on what P3 got or P2 got from P1. So if you did not get all those messages, it doesn't make much sense to process this before getting all those three messages. Okay, so that's why they're causally related. The three messages that P1 sent to P2 and P3 are causally related to this message, because they were sent some time back. This is the last of the third three messages. So this message was the last of the three messages sent, and including this and the prior two messages should have been received. Okay? So that's this algorithm. So the next one is also related to causal ordering, but we don't need to do broadcasting. And this is based on, if you want to send to a specific process, I just send to that process. Okay? So this is called SES after the name of the people who developed it. Okay, so let's go through the examples and understand how this works. So here again we maintain vector clocks. There we did not increment while receiving, if you remember, in the previous algorithm, because it's broadcast. So which means I increment the sending number. So when I send, I increment the number. So everybody knows that that process has sent that three messages. Because here it is unicast based. So if I send from P1 to P3 to P1 something, P2 doesn't get to know anything about that unless otherwise we notify through some other way that P2 that P1 has sent Vidya sent something to P1. Okay, so that's why you have to also increment while receiving. Okay, and we'll see why is that as we go through some examples. Okay, so let's get started. So we have vector clocks, and we increment in doing both sending as well as receiving. So P3 is sending a message to P1. So P3 is sending, so it increments the last P3 entry from 0 to 1, and it sends this message. And this message has a timestamp 001. Okay? And what we need to do here is we also need to maintain, after you send a message, the history of information of the messages and the process IDs and the corresponding timestamps of the message you have sent to those processes. So P3 sends this message to P1, and so it stores in its local state information that it has sent to P1, the message is timestamp 001. So later, when P3 sends another message to some other process, it has to also include this information, as we'll see. Okay? So to get started, there's nothing here, right? So it's 000. So that's why you don't send anything with this message. Okay? But once you send it, that is stored here in the state information. And now when P3 sends another message, now this time to P2, what it does, it increases the clock from this 1 to 2, so it is 002. And you see here, it includes that P2 002 that's going to send, but in the message, it includes that clock 002 and clock value and this from the previous thing. P1001. It doesn't include this information, P2 in this, because it's already here, because this is sending to P2 and this is the clock value. So including this again is redundant, because you see here this is 002 and the clock value, the timestamp of the message is already 002. So why you want to explicitly say this P2002? You see what I mean? Because it's sent to P2 with this timestamp value. So you don't need to include again that information. But you need to include in that message what you sent before this to the other processes. That's maintaining the local state. So this is what is going to P2. So now let's see what P2 does here. P2 is initially all zeros. So when P2 gets this message from P3, it needs to look at this. And we can call it attachment. It's added to the message, so we can call it as attachment for reference purposes. So the attachment, P2 sees if there is some listing for P2, but because what this attachment means is, it has a history of all messages that were sent from one process to another process. So this indicates that somebody like P3 has sent a message to P1. But there's no entry here for P2. So when there's no entry for P2, what does it mean? P2 doesn't need to wait to receive messages from some other process before accepting this message. Only this entry for P2 in this message, P2 has to wait to receive that message. But there's no such entry, so which means P2 can accept this message. Okay? So P2 goes and accepts it, so it is receiving even here. So it first increments its clock value from 0, 0, 0 to 0, 1, 0 because of receiving is P2. And then what it does, it takes a component-wise maximum of this with the message timestamp. The message timestamp is 0, 0, 2. So the maximum of 0 and 0 is 0, 1 and 0 is 1, 0 and 2 is 2. So this is now the new timestamp clock value at P2. Is that clear? Any question? The reason why it's accepting right away is the history or the attachment in the message doesn't have an entry for P2, which means there's no message sent to P2 prior to sending this message. If something was sent, as we see in the later cases, then P2 has to wait for that message to be received. In this case, there's nothing sent prior to this for P2. Okay? Okay, let's do one more thing to be clear now. Now, P2 after receiving this sends a message to this. Of course, now what P2 has to do? It got this information from whom? P3, right? So it updates its clock as well as it learns from P3 that the message has been sent to P1 with this timestamp. So it has to store in its local information that something was sent to P1 with timestamp 001. Okay? So whatever you learn from this message, you have to buffer it in local state. So now when P2 sends a message to P1, what it does, it first increments its clock value. This is P2, so it increments this from 1 to 2. So this is 0 to 2. And then what it does, there's already an entry for P1 because you know whenever you send something, you have to put it in local state. So it needs to put this information that it's sending a message to P1 with this clock value. So it updates this entry P1, but it is putting this timestamp, it's overwriting this with this, right? But in the message that you send to P1, you need to attach what? Whatever you know before sending this. Remember, we have to include in the attachment only things which are sent before sending this. Okay? So before sending this, what is the information that P2 has for P1? Something was sent to P1 with the clock timestamp 001. And this message is sent to timestamp 022. So that's what is here. This is the timestamp of this message to P1. But what was sent prior to this to P1, this is what it was sent prior to this to P1. Right? So now P1 gets this. What it does, it checks its local clock value and this one. What does it mean? Something was sent to P1 with this timestamp 001. And this message was sent after whoever sends this process P2 received that message with this, or at least got to know that information. How it got to know that information? Through P3, through this message, right? So P3 told in its message to P2 that it has also sent something to P1 with this timestamp. So P2 conveys that or forwards that along with this own message as an attachment information. So now P1 gets to know from this that something has been sent to it with timestamp 001 and its local clock value is still 000. So the local clock value should be at least greater than or equal to, greater than this, right? Or equal to. Right now it's not, which means the sender of this message, P2, knows something about P1, which P1 itself doesn't know. P1 has been sent a message with this timestamp, which P1 has not got, which means that it has to buffer this, it cannot deliver the message. So it has to just wait until this message comes, the one that you sent from here. It goes all the way and comes here. So this message, nothing was sent prior to this to P1, right? Because it doesn't carry the attachment because nothing was sent before. So it will be just 001, the timestamp value. So as P2 accepted this message, because P2 accepted this, why? Because there's nothing telling P2 has been sent something. So if the attachment doesn't have information about that particular process, the process can go ahead and accept that message. So in this case, the attachment, there's no attachment telling P1 to send something. So when P1 gets this message, it can just blindly accept it increments its own entry from 0 to 1 because of receiving, and then it takes a component-wise maximum. So 1 and 0 is a 1, and then 0, 0, 0, then this is already a 1 here, so it changes this to a 1. So that's the clock value at P1. So now you see here, P1's clock value is 101. You compare that with the thing just buffered, not yet delivered, which is 0, 0, 1. So 101 is greater than or equal to 0, 0, 1. So which means P1 got to know what it was supposed to know before this message is to be delivered. Right? Because this message carries information that something was sent to P1 with this timestamp. And if P1 has received it, its clock value would be greater than or equal to this clock value, timestamp value. And that's what it's now. P1 has received that message, so its timestamp is 101, the clock value, and it is greater than or equal to this. So now it's okay for P1 to accept this message. So it will be another receiving now. So it's not delivered here. So you increment for receiving only when you deliver it. So this is incrementing 1 to 2, this thing. This is for P1. And then you do a component-wise maximum. So temporarily it is 2, 0, 1. Just this 1 is incremented to 2. And you take a component-wise maximum. The timestamp of this message is 0 to 2. So maximum of 0 and 2 is 2. Maximum of 0 and 2 is again 2, and 2 and 1 is 2. So you have to take a timestamp with the component-wise maximum will be timestamp of the message. Okay? So essentially what we do here, when you send something, you store in your local state and include in that message as an attachment things that you know were sent to all the processes prior to this message, prior to sending this. So you see here, when P3 sends a message to P2, what it does, it includes in this message everything that was sent to the other processes prior to this. So what was sent to the other processes prior to sending this? P3 has sent P1 001. It itself has sent. If you got to know from somebody else, you also need to include that information. In this case, there's no other information here, so just include this. And P2 has to copy that information and store it in its local state. And when this P2 forwards sends a message to P1, what does it do? It needs to replicate that information here. Because if P2 did not have include this information and just sends 0 to 2 to P1, how could P1 know that something was sent to it prior to sending this? You see that? Because this is the causal dependency. The causal dependency is what? This was sent, and then this was sent, and this is sent. So which means this sending event is sent after happened before this sending event, right? So when you send, the sending event of this has happened before sending event of this, the receiving event of this should happen before receiving event of this, right? So, and it's all unique as based. So how could P1 get to know that something was sent to it if we don't include this? So that's why a process kind of piggybacks all those information that about messages that were sent to the different processes, the latest clock value of those messages. Okay? So if you notice here, when P2 sends this message to P1, it updates this with what? Already just P1 001, but now P2 itself is sending a message to P1 with this timestamp 032. So it updates that from 02. So later, after some time, if P2 is sending something to P3, can anyone tell what should be the clock value and what should be the message? 032 should be the thing, and then how should it update its local state as well as the attachment to the message?
It should be
louder.
P1022 and P1001.
Where? Here or here? The message or here local state? The local state. Local state is currently this P1022, right? And so you cannot change that. It has to be still there. and it is sending this to what? P3, right? So it has to also store that information that it has sent this to P3, right? And then in the message, what does it need to include? The timestamp, which is 032, good. And after that, what else? The history, which is
P1.
good. Things that were sent prior to this. So things that P2 have been sent to any other process prior to sending this. So this entry is not included here because, as I said, it's redundant because this is sent to P3 with timestamp 032. So there's no need to include this. Okay? So you include this information to this. Okay? No, because P1001 was here, right? And after it sent this message to P1, the history needs to be updated. You don't need to maintain multiple information about P1. Because this is sent after receiving this, right? So if you include this, it kind of conveys the information that something else was also being sent implicitly. Okay, so you include one the latest timestamp of the message that something has been sent to the process. So since this message was sent after receiving information about this, then if you include this, it implicitly includes information about something that was sent prior to this, which is 001. So that's why after sending this, you maintain only this information in local state, P1022. And even here, that's what you maintain. Okay? Clear? So later, even if this guy sends something to another message to P3, let's see what should be the changes. Can anyone tell what should be the changes?
Time to 042.
The time is going to change to 042, then you have to put your history. So what should be in your history now? Here, the local state or here? Local. So let's do local first. What should we include? P3. Okay, you're sending this also to P3, right? So you include in your local state the up-to-date information, which means you include 042 because this is sent with timestamp 042, right? And don't forget this P1. P1 is still there. The information about P1 is still there. I'll tell you when that can be deleted in another example, but right now this should be there. Okay? And what should be the message? You should have the timestamp, right? So this one was sent 032, so this one should be timestamp 042. Then P1022. What else? Anything else? Is it? Before sending this, what was the local state? P3032. Because you didn't include that here because prior to sending this, there's nothing sent to P3 or nothing known about P3, right? But prior to sending this, you know something about P3. That P3 has been sent either by this process or even by some other process, but the timestamp of that message is this. Why that is important here? Because let's say that this message that P1 sent with timestamp whatever we had, let me change it a bit. If it takes a while and comes like this, okay? And what was the timestamp? 032 and P1022, no entry for P3, right? So when P3 gets this first, it sees that something has been sent to it with timestamp 032, right? And what was it? What is its local clock now? The local clock is what? 002, right? That's P3's clock, isn't it? So there's no even happening, so it will remind to be 002. So it checks, it compares its local clock with the clock timestamp of the attachment here. It says P3032. So what is the requirement? Its local clock should be greater than or equal to this timestamp, right? So is that clear? Its local clock value should be greater than or equal to this in order for it to be accepting this, because that's what this means. This message carries this information, the history of things that were sent to the other processes, including P3. So this conveys what? something has been sent to P3 with this timestamp prior to sending this message, which means P3 should have got that message before processing this message. And if P3 should have got that message, its clock value should be greater than this clock value, right? So in this case, P3's clock value is not greater than this. Do you see that? So which means P3 has to just buffer it. Okay? So then if this guy comes from here, there's no entry for P3, which means there's no message that is causally or happened before the sending of this message to P3. So P3 doesn't see an entry here, which means it doesn't have to wait to receive any other message. So it can accept this message, and because of that it has to do what? Change its clock value. So how does it change its clock value when it accepts this message? This is buffered, so it's not delivered right now. So this is the event happening now. So what should be the clock value? We should also do it for receiving. As I say, clock increment also for receiving. So it means P3's local clock value 002. So how should it update this? 003 at for the time being, and then do a component wise maximum. Compare 032, the timestamp of the message, with your clock value. So the maximum of 0 and 0 is 0. So that holds good. Then maximum of 3 and 0 is what? 3. So you should change that to 3. And then 2 and 3 is 3. Right? So this is the clock value at P3. So now you compare this with the clock value here in the buffered message. Now we don't see, is it greater now? Which means P3 got to know about this message. Right? It has received it. That's why it is now greater than that. And so it can now process this message. So we have to buffer it, right? So now this is delivered. So when you deliver this, what will be the clock value? 0, 3, 4, and do a component wise maximum with this. What is that? 0, 4, 2, right? So this has to be also 4. Okay? Clear? Any question? Now, when when P3 accepts this message, so this message, the blue one coming from P2, that carries this information. The attachment what? P1 has been sent 022, right? So P3 has to store that in its local state. As well as, see, when you see that, P1 currently has this information, right? And when this message timestamp says P1022 and you already have something for P1, so what you should do? You should change this from P1. Instead of this, you have to store it as what? This P1022. And then continue to maintain P2002. Okay? Now, we could even delete it, which I don't want to say in this example because I don't have all those things marked, but let me tell that if you want. Remember here, you have two entries here, right? So the issue is which ones you will maintain, which ones you will increase or change, which one can be deleted. So when this message comes here, right, what the attachment it carries? P1022. So your clock value for P1 is 001. So which means this message carries something latest than what you know about P1. So you can go ahead and change this from P1 0012 to P1 022. Right? Now what about this? Previously you had for P2 002. So you're wondering whether to retain it or update it or delete it. And this message is coming from whom? P2 itself. And in this message P2 includes this clock value of what? 032. And your estimate of the clock value for P2 002. So you get to know that P2's clock value has increased beyond 002. It is now 032. So which means what? You don't need to store information about this. Because P2 already knows about this message 002. You store this, why? Because if you later want to communicate to P2, you want to tell it that something has been sent to you 002. And clock value 032 indicates P2 has already got this message that was sent to timestamp 002. So there's no need to include in the local state information something about P2, because if you include it and then send it to P2, you want to tell it that something has been sent with this timestamp. But the timestamp here indicates that P2 has already got it and it's about this. So there's no need to store information about P2. But to store information still about P1 because you have not communicated with P1. Right? And your entry for P1 is still like a 0, so you don't know much about P1 in this case. So clear? Okay, so I have two more examples, we'll go through them very quickly now. So it's the same idea, but we got to know, we actually extended the first example. This should be now straightforward. We can put everything together. So we have three processes, 0, 0, 0 is the clock value to start with. So now P1 is sending a message to P2. So P1's local clock value is initially 0, 0, 0, so it increments this to 1, 0, 0, right? And then what it does, it buffers that it is sending P2 1, 0, 0. But nothing was sent, the thing is empty here, right? The history prior to this local state is empty. So you don't need to include any attachment in the message, just send 100, the timestamp of the message, from P1 to P2. Right? Then after you send this message, you send another message, now this time from P1 to P3. Okay? So to send this message, you need to increment your clock for sending. So from 100, you increment to 200. And then your clock, this local state is P2 100, that stays as it is because nothing happens regarding P2 here. But you're sending this to P3, so you add another entry telling P3 200. But now what should be piggybacked in this thing, in this message? What should be sent in this message? 200 is the timestamp. Now why? What about this? Because this is something happened prior to sending this. Prior to sending this, local state said P2 was sent 100. So you need to include that information in this. Okay? So prior to sending this, what was the local state? Include exactly all those information. If there's more than one entry for P3, include that information too. But here there's only one entry, which is for P2. So include that. So now P3 gets this. Now P3 has to decide whether to accept this message or not. How does it decide? It looks at this, timestamp and its attachment and its local clock value 000. Right? So what did I say? How does the process go about deciding? It looks in the attachment in the message whether there is an entry for that process. What is the process here? P1, P2 or P3? This one. P3. Is there an entry for P3 here? No. Which means there is no message that was sent to P3 before sending this message. If there was something, that history would be included here of the message and its clock and the process and the timestamp of that message. Right? There's no such information in this message. So that indicates that this message is not causally dependent on something else that was sent prior to this. So which means P3 can go ahead and accept this message. Okay? So it increments its clock value how? It is 000 to start with, so 001 for receiving, and then do a component wise maximum, so 0 and this 2, and then so change to 2, and then 0 and 2, so 0 and 0 is 0, and 0 and 1 is 1, so that's why it's 2, 0, 1. Okay? And make sure to store whatever is piggyback. So P2 100 is piggyback with the message, so store that in the local state. Okay? Now why is that important? Let's look at that. So after receiving